Okay, welcome again. We'll be finishing up the video that goes over the test retake. This video will cover problems 2 and 6. We'll start 2 right now. So ABCD is reflected about the y-axis and rotated counterclockwise 90 degrees. Translated x minus 2 and y plus 2. Draw ABCD prime and list coordinates of each vertex. We're starting in quadrant number 3, which has a negative negative. It's negative on the x and negative on the y. In quadrant number 3, which when we reflect it across the y-axis will be negative on the y and positive on the x. We'll start with point A. A is at a negative 7, negative 4. When it moves across the y-axis, it becomes A prime, and A prime will be 7, negative 4. So 7, negative 4 for the A prime. B is at a negative 12, negative 7. When it moves across the y-axis, the 12 becomes positive. The negative 7 stays a negative 7. So 12, negative 7 for B prime. C is at a negative 7, negative 10. And C prime will be 7, negative 10. And then finally, looking at D, D is at a negative 2, negative 7. And then when it moves across the y-axis, it will become D prime and will be at 2 and a negative 7. I'll draw in my lines and connect my points, and now you can see that I have the mirror image that I should have. When I do a 90-degree rotation counterclockwise, if you take a look at this, D and B is pointing this way. When I rotate at 90 degrees, D and B will be pointed up. So that's what I'm looking for on this next rotation. We'll start with my points again. My next A prime, I'll do this one in blue. Now the X's and Y's switch places, so the negative 4 will become the X, the 7 will become the Y, and this coordinate part of the coordinate plane will be positive, positive. So this means that A prime will become 4 and 7. B prime will become 7 and 12. C prime, they switch, remember they switch, so 10 and a positive 7. And then D prime will become 7 and 2. We'll plot these points. So 4 and 7, 7 and 12, 10 and 7, and then 7 and 2. So A prime, B prime, C prime, and D prime. Now we see the reflection across the y-axis, we see the rotation from quadrant 4 to quadrant 1. And now we're going to do the translation last. Now if we let us look at this translation, I take the x's, I subtract 2, I take the y's, I add 2. This is my final one. I'll do this in black. My new a prime, subtract 2 will be 2, add 2 will be 9. B prime, subtract 2 will be 5, add 2 will be 14. C prime, subtract 2 will be 8, add 2 will be 9. Subtract 2 will be 5, add 2 will be 4. There are my final points. 2 and 9, 2 and 9, left 2 up 2, so that's right. There's my a prime. B is at 5 and 14. C prime is at 8 and 9. I think my B's in the wrong spot. 14 would be right there. And then D is at 5 and 4. Should be 5 and 2. Oh, it's 5 and 4. I'll connect my dots. And there is my final figure. So A, B, C, and D prime. All I really need to see to give you the points is the final diagram and then the coordinate pairs for each vertex. Our next problem is problem 6, and this is the hardest one on the test. Show that ABCD is congruent to ABCD prime by finding the transformations that map. It should be ABC to ABCD prime. The dilation must take place last. Before we begin, I'm going to take a minute and kind of explain what's happening over here. The first thing that takes place, and we'll talk more about it in depth as I go, we do a reflection across the y-axis. So ABCD will end up over here. This square has to be translated so it fits on the lines of dilation. Now let me go ahead and draw one. We'll draw A, and let me do this in black. We'll zoom in. This point A prime here has to be moved up 1, 2, 3 over 1 to hit there. Let me make this one in red. This point is hard to find on this line. It's really hard to find if you try to go from step 1 to step 2, which would be this point here. This is the idea that I have. We know this is the dilation. The dilation will take this larger square and reduce it by half and shrink it down here, but it follows this line of dilation. Somehow this has to be moved up to here. The idea is, when I do the dilation front ways, the dilation is 1/2. If I want to go backwards to find out where this square is translated to, I reverse the dilation. So I'm going to times this point by 2. It's going to find this point, and then I'll know my translation perfectly. So let me erase this and we'll go ahead and begin. Let me shrink this down just a little bit. we want to do a reflection around the y-axis. This is not a rotation, it's a reflection. So I take the point A, which is 5, negative 5. It moves across the y-axis, and that new point will become a negative 5, negative 5. Right there. B, which is at 13 and a negative 5. B prime will become a negative 13, negative 5. And we will do C. C is at a negative, or 13, negative 13. It will become a negative 13 and a negative 13. I will go ahead and draw my squares. Now we can see where D is going to line up. There is my square that has been reflected across the y-axis. Now let's take a look at this one, this A, and I'm going to do this one in black because it's the last step. So this A prime is at a negative 3, negative 1. I want to reverse the dilation. The dilation going front ways is 1/2. The dilation going backwards will be 2. The point A prime is at a negative 3 and a negative 1. I will times that by 2. Now it becomes an A prime of a negative 6 and a negative 2. Negative 6, negative 2. If I take B, change to black, so this one is in black, so that B prime is at a negative 7, negative 1. I times it by 2. The new point will be negative 14, negative 2. And we will do C. This C is a negative 7, negative 5. I'll times that one by 2. And you see what happens to all of this? It's a negative 14, negative 10. C's at a negative 14, negative 10. B will be at a negative 14, negative 2. You see how all of them has gone to the left 1, up 3, to the left 1, up 3, the left 1, up 3. So that middle translation, that second step that's so hard to find, now we know how to find it. We simply reverse the third step, which is the final step of the dilation. We do it backwards. It finds that point of that point that's on the line of dilation. You see, there's the A, there's the B, there's the C, and then there's the D. So our final steps, we do a reflection, over the y-axis. We do a translation of x minus 1, y plus 3, and then that last step was required to do a dilation. Now you may ask yourself, well, do I put 2 down or do I put 1/2 down? We're going forwards on this one, aren't we? So I'm starting here, and that dilation is moving this way, so it's 1/2. When I went backwards, it was 2. So the dilation is 1/2. Okay, so that's how you do the last problem, and thanks for watching.